see about discrete convolution. So last class we have seen about convolution integral. So similar to convolution integral, you have discrete convolution for finding the output of a discrete system. So let us consider a system like this, say with impulse response h of n. So impulse response of the system is h of n. So when it is having an input, say x of n, everything is in terms of n. It's a discrete world. Say the output is y of n. So for an LTI system, if you know the impulse response h of n and if you know the input x of n, you can use convolution operator, say the discrete convolution operator, to find the output. So that is the use of convolution operator. Now let us see the mathematical part of discrete convolution operator. So we have seen that in case of continuous signal, we had integral minus infinity to infinity, say x of k into h of n minus k. That was the equation used, right? Now coming to discrete world, instead of integration, you will have summation. That is the main difference. So instead of integration, you will have summation. So the y of n is given like this. Y of n is sigma, say k, the variable is k, I repeat, the variable will be k. K varies from minus infinity to infinity, where n is a constant. So k varies from minus infinity to plus infinity, x of k, h of n minus k. So this will be the mathematical equation to find discrete convolution between two sequences. Now let us consider an example. Again, here also we will have two methods, one using direct equation and another one is using the graphical method. So let us see one example. You consider a system who is having an impulse response, say h of n, and input, say x of n, and let's try to find the output y of n. So assume that x of n is say u of n. We'll take a simple problems, and h of n equal to say 2 raised to n into u of n. So this is my x of n and h of n. Let's find the convolution between these two sequences. So our task is to find the output y of n. So y of n is simply x of n convolution h of n. So first let us try with direct equation, that is sigma k equal to minus infinity to plus infinity x of k, right? So x of k into h of n minus k. So as per the equation, minus infinity to infinity, x of k. What is x of k? It's u of k. The index has been changed to k. H of n minus k. H of n is 2 raised to n u of n. So h of n minus k will be 2 raised to n minus k into u of k, u of n minus k. Okay. Now focus on the signal, say u of k. So u of k expands from 0 to infinity. And what about u of n minus k? U of n minus k is the folded and shifted version. So it varies from minus infinity to k. Hope you remember this part. Or else have a look at this. So u of n will be like this. This will be u of n. So u of k, I can call u of k. U of k will be like this. Let the axis be k. Now we have to perform, you need to plot u of n minus k. So u of n minus k means u of minus of k minus n. So first you have to perform reversal, then you have to right shift it by n units. So when you perform reversal of the sequence, you will get this one. This is the reversed sequence, right? And when you right shift it by say n units, this is how the signal will look like. So you can say that the integral limit is from the lower limit and upper limit will be like minus infinity, or signal span will be from minus infinity to n. That is what we have mentioned here, minus infinity to, it's not k, it's minus infinity to n. Okay, now let us see, or let's simplify the summation expression. So you will have sigma, so 0 to infinity and minus infinity to n. So the product will be, the resultant will be from say 0 to n. So you will have the integration limit from 0 to n, and the amplitude will be u of k, it's u signal, so that will be 1 only. So 1 into 2 raised to n minus k will be the expression. Now let us simplify this. N is a constant, you can say, so let me take 2 raised to n outside, then sigma k equal to 0 to n 2 raised to minus k. So substitute different values of k. So you will have k equal to 0, you will have 1 plus, when you substitute k equal to 1, you will have 2 raised to minus 1, that is 1 by 2. K equal to 2, you will have say 1 by 2 whole square plus etc. up to, how many terms will be there? 0 to n. So you will have n plus 1 terms will be there, n plus 1 terms. So when you simplify this, you will have a GP. So the first term is 1 and common ratio is 1 by 2, and you will have n minus 1, n plus 1 terms. Okay, you will have n plus 1 terms. So you can use the equation a into, so a is 1 into 1 minus r raised to n. So it's 1 by 2 raised to n. Here I have n plus 1 terms, so I will write n plus 1 divided by 1 minus r. R is 1 by 2. A into 1 minus r raised to n by 1 minus r, that is the expression. So you will have 2 raised to n into, in the numerator, this is 1 minus 1 by 2 all raised to n plus 1. Denominator is 1 minus 1 by 2 will be 1 by 2. This 2 will come here. So you can write it as 2 into 2 raised to n, or simply 2 raised to n plus 1. Okay, so you will have 2 raised to n plus 1 into 1 minus 1 by 2 raised to n plus 1. 1 minus 1 by 2 raised to n plus 1. Now if you open the bracket, 2 raised to n plus 1 minus, so you have 2 raised to n plus 1 into 1 by 2 raised to n minus 1. So 2 will get cancelled, so this will become 1. So you can write this as into u of n as the final answer. So this is what we got using direct equation. When you use the discrete convolution equation, you will get this answer. Now let's try the same thing with graphical method. Okay, let's try to find the same thing using graphical method. So as we discussed earlier, similar to your continuous domain, here you need to do the same process in the discrete world. That's it. So first let us plot x of k and h of n minus k. So you have to plot x of k and h of k. You have two signals. So one signal has to be folded, one signal has to be folded. So choose, as we know, x of k convolution h of k is same as h of k convolution x of k. Whichever signal is flexible to fold, you take it as the second signal. So in this case, let me plot the two signals first. So you'll have u of k and 2 raised to n into u of k. That is your signals, right? One is u of k, second will be 2 raised to k into u of k. So I will do the reverse operation. Let me try to fold the second one. Okay, so h of k was like this. This was h of k, and this is x of k in our case, right? This is u of k, and this is say 2 raised to k into u of k. So it's an exponentially growing signal like this. So I think it's better to fold the x of k. So what I'm trying to do is, I'm going to plot x of n minus k. Okay, h of n minus k, because I am trying to find this one, say y of n is equal to sigma, or convolution you can sigma x of k h of n minus k. Instead of that, I am going to take h as the first signal. So you will have sigma h of k into x of n minus k. Okay, because of commutative property you can write like this. So I am going to plot these two signals first, x of k and x of n minus k. So this is x of n minus k. You have to fold x of k, then you have to shift it by n units. So it will look like this. Span is from minus infinity to n, and h of k is already plotted here. So we are going to operate with these two signals. So this is your first signal and this is your second signal. Now you have different cases. You can say that this point is 0. So when n is less than 0, when this is the first case, when n is less than 0, what is your y of n? Product of these two, product of 1 and 2 will be 0, you can say. Okay, there is no common point. Now next case, when value of n is greater than 0. So when n is greater than 0, you have to overlap the second signal. Let me try to plot in same graph, same wave, same axis. Say this is your exponentially growing, say 2 raised to n signal. Okay, now say that is wave number 1. Now let me overlap wave number 2, which is coming from minus infinity to n. So let me try to overlap this with the first signal. So this is, we have marked it as 1. So this is 2 and the green colored signal is 1. Now what will be the product? So here you can say that in this region it vanishes. So the common region is from 0 to n. Okay, after that also, since second signal is there, your product will be 0. So you can say that your y of n will be y of n equal to say your y of n equal to sigma n varies from 0 to k varies from 0 to n. Then what is the signal over here when you multiply 1 with 2? So amplitude of the signal 2 is just 1, it is unit step. So amplitude of signal 1 was 2 raised to k, that's it. So when you expand this, you will have first term as 2 raised to 0, 1, second term is 2 raised to 1, 2 square plus etc. up to how many terms will be there? Again you will have n plus 1 terms. So again this is a GP, but see that the common ratio is greater than 1. So you have to use this equation, a into r raised to n minus 1 by r minus 1. So when you use this equation, say the first term is 1 into common ratio is 2 raised to n minus 1. It's not n, we have n plus 1. Okay, because number of terms is n plus 1 divided by r minus 1, 2 minus 1. So you got it as 2 raised to n plus 1 minus 1. So you can say into u of n will be there, because this is valid only for n greater than 0. So let's compare with the first method. Answer of the first method, that was 2 raised to n plus 1 minus 1. Now here it is 2 raised to n plus 1 minus 1, the same. So these are the two methods for calculating discrete convolution. There is another method when when you say you have finite number of elements in both the sequence. There is another easy method. So let's see a case where you have x of n is say 1, 2, 3, 4. You have finite number of elements in this, and say h of n is 1, 2, 1. Okay. So when you want to perform discrete convolution, you can use graphical method or again the equation directly, but instead of that we'll see another method right now. So what we have to do is 1, 2, 3, 4. This is my first sequence. You can take it in any order, and the second sequence you have to write over here 1, 2, 1. Now you multiply 1 with each and every term over here. So 1 into 1, 1 into 2, 1 into 3, 1 into 4. Similarly you multiply with the next element, that is 2, 2 into 1. So you have 2, 2 into 2, 4, 2 into 3, 6, 2 into 4, 8. Again with the next element, that is again 1, so this will be 1 2 3 4. Once you're done with this table, you can draw zigzag lines like this. Carefully draw the lines. Okay, so once you complete this, you can simply write y of n as first element will be 1, second element will be sum of these two, 2 plus 2 4, third will be 4 plus 3 7 plus 1 8, next 6 plus 4 10 plus 2 12, 8 plus 3 11, and last element will be 4. So this will be the result. And there is about the width property that we have seen in the continuous case convolution. Here also you will have the width property. That means if you have say m elements in the first sequence and n elements in the second sequence, then the total length will be m plus n minus 1. I repeat, if you have m elements here and n elements here, the result will have say m plus n minus 1 number of terms. So in this example you have 4 and 3, m as 4 and 3, so 4 plus 3 7 minus 1, 6 elements will be there, 1 2 3 4 5 and 6. So that's all about convolution, discrete convolution.